While all blockchains can process code, most are severely limited. Ethereum, on the other hand, is very different. Rather than giving a limited set of operations, Ethereum allows developers to create decentralized applications. Hi guys, this is Arya from Edureka, and today's video is all about building decentralized applications using Solidity language on Ethereum's platform. This tutorial is meant to provide insights into the building of decentralized apps on Ethereum's platform. Just to be more specific, let me show you guys what you're going to learn in today's video. So, we'll start our class with a short introduction to decentralized applications. Then we are going to talk about the building blocks of decentralized applications at a very macro level. Next, we'll discuss the various tools and technology stacks for building a decentralized app. Drilling down further, I'll tell you guys about the major decentralized application building tools. Lastly, I have a pretty interesting demo to show you guys, which is a property transfer use case using Ethereum. I hope that gets your attention. Alright, now let's go back to the days when Ethereum was not developed, and Bitcoin was the only ruling decentralized application running on a blockchain. So before the creation of Ethereum, blockchain applications were designed to do a very limited set of operations. Bitcoin and other cryptocurrencies, for example, were developed exclusively to operate as a peer-to-peer digital currency. Now developers faced a problem. Either they had to expand on the set of functions offered by Bitcoin and other type of applications, which is a very complicated and time-consuming task, or they had to develop a new blockchain application and an entirely new platform as well. Recognizing this predicament, Ethereum's creator, Vitalik Buterin, developed a new approach. He devised a platform that gives endless opportunities to develop blockchain-based applications by writing basic building blocks of programs called smart contracts. Now let's talk about Ethereum. So Ethereum's core innovation, the Ethereum virtual machine, is a Turing-complete software that runs on Ethereum's network. It enables anyone to run any program, regardless of the programming language, given enough time and memory. The Ethereum virtual machine makes the process of creating a blockchain application much easier and efficient than ever before. Instead of having to build an entirely original blockchain for each new application, Ethereum enables the development of potentially thousands of different applications, all on a single platform. Now let's see the differences between a traditional web app and a decentralized web application. So on the traditional server architectures, every application has to set up its own server that runs their own code in isolated silos, making sharing of data very hard. If a single app is compromised or goes offline, many users and other applications are affected also. Decentralized applications, on the other hand, run on a blockchain. Anyone can set up a node that replicates the necessary data for all the nodes to reach an agreement and can be compensated by users and app developers both. This allows user data to remain private and apps to be decentralized like the internet was supposed to actually work. So what exactly is a decentralized application? Decentralized application is a program which is run by many people, which either uses or creates a decentralized network for some specific purpose. Example, connecting buyers and sellers in some marketplace, sharing files, online file storage, or maintaining a currency. Ethereum-based decentralized applications are called dApps, which stands for Decentralized Applications. Ethereum-based decentralized applications typically consist of an HTML or JavaScript web page. And if viewed inside the Ether browser, the browser recognizes special JavaScript APIs for sending transactions to the blockchain and reading data from it too. In summary, a dApp is essentially a glorified web application which can tap into the Ethereum network and the blockchain also. To point it out, dApps can have the following few characteristics. Firstly, they run on a blockchain. Secondly, their code is made open source and operates autonomously without any person or group controlling most tokens. Thirdly, they generate decentralized application tokens to provide value to their contributing nodes. And lastly, users are granted access to them in exchange for tokens. Okay, so now let's discuss the building blocks of a decentralized application. On a macro level, decentralized application is built using three major components, namely the Ethereum network, smart contracts, and the web frontend. So basically, a smart contract is written in Solidity or any other equivalent language which can be compiled to Ethereum's bytecode, which is called EVM bytecode. Such a smart contract is what allows a decentralized application to connect to a blockchain. A dApp is similar to the traditional web application that uses HTML, CSS, and JavaScript to render a page. But instead of using an API to connect to a database, the smart contract is the bridge that connects to the blockchain. Now, as you guys can see, the image does illustrate that smart contracts are playing the role of the API connector to the blockchain. Like building a normal web or mobile application, creating a decentralized application commonly requires a few things: computation, file storage, external data, monetization, and payments being the few. The community has made a lot of progress building ecosystems in the past 4 years. While it was borderline impossible to build a decentralized application in 2014, in 2018 it's feasible to build a basic Dapp that requires minimal computation and file storage. The Web3 ecosystem has come a long way to develop technology stack that developers can build upon. There are two pillars to a Web3 project setup. Firstly, the Web3.js file, and secondly, the test RPC, which is the local Ethereum blockchain. Now, Web3.js is the most advanced Ethereum JS library out there, and test RPC is currently the simplest way to get a local node running. Now, here is a listing of technologies in a Web3 stack. The components in a development stack is integrated in such a way as it provides an environment to develop and deploy a decentralized application in Ethereum's network. Okay, so let's drill down to a micro level when I'll discuss some of the major tools used for developing Ethereum-based decentralized applications. So first things first, to develop any application, we need a programming language. Similar to develop a decentralized application, we need to first create a smart contract. So the programming languages that are used for smart contracts are, as you can see, are Solidity, Serpent, and LLL. Solidity is a contract-oriented high-level language with syntax that is similar to that of JavaScript, and it is designed to target the Ethereum virtual machine. Serpent is a high-level language that is designed for writing Ethereum contracts also. It is very similar to Python, but as of September 2017, Solidity is the preferred language of development for Ethereum developers. There is also another language called LLL. It is a simple and minimalistic language, and it is based on Lisp. And as you guys can guess, it also stands for Lisp-like language. Okay, so out of these three, the most popular language is Solidity. The world uses it for writing smart contracts on Ethereum, so let's talk about it a bit more. So Ethereum Solidity is a contract-oriented high-level language with syntax very similar to JavaScript. Solidity is a tool that is used to generate a machine-level code to execute on EVM. The Solidity compiler takes the high-level code and breaks it down into simpler instructions. The encapsulated code is called a smart contract. Now, to start coding a new language, you want the easiest development environment that will help you through the bugs so you can learn from your mistakes as quickly as you go. Remix should be your go-to option for writing a contract. We also have various editors for Solidity code programming, like Visual Studio Code, which is a source code editor developed by Microsoft. Another popular editor is Atom, which is a free open source text and source code editor for macOS, Linux, and Windows. But I think Remix is the most user-friendly, and let me show you guys why. Okay, so let's head over to Remix first. Yeah, so as you guys can see on Remix's site, it has a lot of features and functionality. You can write your code on this editor out here, and it'll start compiling and show you compilation errors right out here. Next, you have the Run tab, and you can run on various environments like the JavaScript VM, the injected Web3 provider, or a normal Web3 provider. Above that, you have an Analysis tab that lets you analyze your code, and then you also have a debugger, which you can actually use for debugging your code by block number or transaction indexes. Okay, so coming back to the video now, we have talked about the programming languages and the IDEs, or the browsers and editors for writing Ethereum code. Now, suppose you have written a code, or let's say a contract, you want to deploy the contract onto a blockchain. This is where clients are used. An Ethereum client is just a term. It refers to any node that is able to parse and verify the blockchain, its smart contracts, and everything related. It allows you or provides you with the interface to create transactions and mine blocks, which is the key for any blockchain interaction. The client implements Ethereum's protocols. These clients will replicate all blocks from the network to a local system until and unless they're in light client mode. These clients mines Ethereum's blocks and manages Ethereum accounts. Also, they send and receive Ether, which is Ethereum's network-specific cryptocurrency. There are also various clients supporting Ethereum's network. We have Get, which is written in Go language given by Ethereum's foundation. Then we have Parity, written in the Rust language provided by the company called Ethcore, and we also have clients written in Python, Java, and JavaScript languages as well. Out of all those many popular implementations nowadays, Go Ethereum or Get is the most popular. Get is an official Golang implementation of Ethereum's protocols. It is written in Go, fully open source, and licensed under the GNU LGPL version 3. Go Ethereum is available either as a standalone client called Get that you can install on pretty much any operating system, or as a library that you can embed in your Go, Android, or iOS projects. Now we have browsers for connecting to the blockchain. Two of the most popular browsers are MetaMask and Mist browser. So MetaMask allows you to run Ethereum decentralized applications right in your browser without running a full Ethereum node. It is an extension that is available for Chrome, Opera, and Firefox and uses a service called Infura. Infura has Geth or parity blockchains nodes running already all the time. We also have a browser called Mist. Mist is a full browser and it has its own blockchain node implemented. Mist is integrated with Geth node. So basically you can store Ether, send transactions, deploy contracts, and more with Mist. You can use a native application to play around on the blockchain or a testnet while you get the hang of this whole blockchain. Super useful for quick transactions. But I mostly prefer MetaMask for connecting to the blockchain, so let me tell you guys a little more about this. So let's head over to MetaMask on the Chrome Web Store. So as you guys can see, MetaMask is available as an extension for Chrome. What it does is it injects the current Web3 API into the Chrome browser so that you can actually read data from the blockchain and send transactions to it in a very secure and seamless manner. Okay, so coming back to our video, let's talk about the frameworks. So the only framework that is available for development purposes on Ethereum is Web3.js. Just like you have Geth, Mist browser, or so on to communicate with Ethereum node, there is also this library called Web3.js, which can be used to interact with the node. Since it is a JavaScript library, you can use it to build web-based decentralized applications. So who'd like an application without an interface, right? If you want to build a decentralized application, you're going to get very personal with Web3.js library. Web3.js is going to be the interface you'll use to interact with the blockchain if you're trying to make something people won't actually hate. Although it is tempting to keep using Remix, you should move on once you get to the point where your decentralized applications compiles very properly. Next, you should use tools such as Truffle and TestRPC that help you simulate a real blockchain so you can test your dApps in a more realistic situation. So let's talk about Truffle first. Okay, so let's head over to Truffle's website once. So as you guys can see by their website, it claims that it is definitely your Swiss Army knife if you're developing on the blockchain. So until now, the only way we used to interact with our contracts was to deploy them manually through a node console into a TestRPC node and then load them using Web3. Now let me introduce Truffle to you. Truffle is a development environment, testing framework, and asset pipeline for Ethereum, aiming to make life as an Ethereum developer easier. Truffle provides the building blocks to quickly create, compile, deploy, and test blockchain applications. There are many tools and applications that fall under the Truffle suite, which is there to make your life easier. Let me show you a few of them. So first of all, we have Ganache. So Ganache is the same thing as TestRPC. Actually, TestRPC was deprecated and renamed to Ganache. So Ganache is a local test node that is used by Ethereum developers to test the interactions of their applications that they have developed with the blockchain that they're going to deploy it on. It's a very nifty tool if you're actually going into all the things like gas price of each transaction and how your transactions pile up and how your things are getting mined and how your consensus protocol works. Next, we have Truffle boxes. Truffle boxes allow you to focus on what makes your dApp unique. In addition to Truffle, Truffle boxes can contain other helpful modules like Solidity contracts and libraries, front-end views and more, all the way up to complete example of decentralized applications. Pretty interesting, right? Alright, it seems like I haven't talked about the networks yet, so let's get on to them. Ethereum has three types of networks. The mainnet, which lets you connect to the main blockchain. Then there are test networks. To test your decentralized application, Ethereum gives you the option of three types of test networks. So we have the Ropsten network, the Coven, and Rinkme. So apart from using test networks, you can create a custom network as well for local development. For local testing, we can use TestRPC or Ganache CLI that were discussed earlier. Now let's see how all these pieces fit together. So far, we've seen the various tools required to build an Ethereum Dapp using Solidity. Now let's see how these tools actually interact with the blockchain when you try to create and deploy your Dapp on the Ethereum network. So basically, a decentralized application front end can be made using any web application. The front interacts with the Web3.js, and this Web3.js library connects with the Ethereum node using JSON RPC. Apart from using Truffle for deploying and creating decentralized applications, you can also use Geth command prompt. Alright, so after a dApp is created, it is deployed onto the network. Here's how it is done. So the smart contract is compiled into a bytecode and is deployed to any of the peers. The static files are downloaded into the browser and it is then connected using Web3.js via JSON RPC. And this is how a user can interact with the deployed app. Okay guys, so it's finally time that we commit to the demonstration that I had promised you guys at the beginning of the class. So before I actually start with the coding, let me just prep you up with the scenario that we are going to implement on blockchain. It's quite simple. Suppose you wish to transfer a property to your close one. Now, if you would do that with our existing system, then you would find that there are certain problems or limitations that exist there. What happens is that since we use a central authority to transfer ownership of our property, this can cause delay, attract a lot of extra expenses, and also there's a chance of fraud. So how does blockchain be helpful here? So by using hashes to identify every real estate, it makes everything publicly available and searchable. Also, proponents argue issues such as who is the legal owner of a property can be remedied. Basically, blockchain is not going to replace government. Concerning how land is registered and monitored, it will make governance of land registration the simplest and most corruption resistant possible. Most importantly, this will reduce frauds and ensure that properties cannot be sold more than once over the same entity. There is good reason to think that the blockchain technology could serve as the basis for a more reliable, cheaper, and more efficient land registry. In my opinion, one popular blockchain use case that has remained generally outside scrutiny has been land title projects. It's going to flourish in the coming years when industrialists seem to realize the true potential of blockchain technology. I hope you'll agree with me out here. Okay, so without further delay, let me show you guys how a property transfer can be used in a decentralized way. Basically, we are going to code a smart contract which is capable of handling the logic for property transfer. There are a few actions that we're going to perform. So firstly, we're going to insert some dummy properties to replicate the real world. These properties shall have basic characteristics, for example, address, location, flooring, etc. Make sure you create the demo entries from a single owner. This single owner shall assign the properties to you. If you try to replicate it in the real world, generally the government shall be signing the documents which say that now you're the owner of this property. So here in this case that you are building the solution for a government. Government shall be assigning the properties after verifying your original documents. Hence make sure that you generate the dummy properties by a single owner and this shall be distributing it to multiple people. Next, any address can send the property from his account to other owners and check the ownership of the property before transferring it to other owner. Try to include as many general parameters as possible to keep the smart contract almost replicating the real world transaction. After the successful transfer of the property, we need to be sure that the old owner is not able to send the property again. And finally, the new owner must be able to send the freshly received property to any owner that he wishes to. Now, like I told you, we're going to develop a smart contract. So basically, we're going to use Ethereum's platform for development. We'll code in Solidity language. And after that, we're going to code in Solidity language on the Remix IDE. And we're going to use Ganache CLI as our test network. So let's get started. So like I told you, we're going to develop a smart contract. So basically, we are going to use the Ethereum platform for development. We'll be writing our code in Solidity and using the Remix IDE for compilation and deploying. And we're also going to use Ganache for our test network, and to actually see our blocks have been transferred, we're going to use this thing called Block Explorer. So let's get started. So I'm going to write my code bit by bit and explain once I'm done writing a bit, and that's how we're going to go about it. Okay, so let's get started. So first of all, we'll have to open Remix on Chrome, and that's where we're going to write our code. So let's set that up. Yeah. So I'm going to write my code a little bit by little bit, and then once I'm done with a good chunk of it, I'm going to explain what I've done. So let's get going. So, okay, so let me just explain what I've done till now. We've created an address of the DA, which stands for Development Authority. So he'll be in charge of allotting everything and all the transferred properties. So this is going to take the first address of our test code when we run it. So next we have the total number of properties, which is a UNT. Next, we've just made a function to start the property transfer, and it'll be the DA as the message.sender, which is basically the first address. Then we've created a modifier which will check if the sender is the DA in fact. And then we've created a simple structure for a property. And our property will have two members, and that is a name and whether it is sold or not. Next, we've created a mapping, and this mapping actually points to another mapping of an address. And this is for the property's owner. Next, we have the individual count of property per owner, and that is also denoted by a mapping, which is from address to UN 256. We've also created two events, and these events will be triggered as the name suggests. When a property is allotted, this event will be triggered, and when the property is transferred, these events will be triggered. Now let's go ahead and write the logic for our property transfer. So let's go to the functions that we just created. So the first function that we created is get property count of any address. This shall give us the exact property count which any address owns at any point of time. So this is basically done by passing it the address of the owner that we want to check, and it returns the number of properties that is owned by him. So we just run a for loop on the properties that is owned by him, and we increase the count and we return the count once we've done that. Next function is for allotting properties. So this function shall be only called by the DA, and this is only after the verification of the owner's address. So obviously we have the whole modifier only owner that we had created before to check if it is actually the owner or not. And if it passes everything, the property shall be allotted according to the logic that we give. So the property's owner will get mapped with the name, and it'll be mapped to the property name. And then we'll also fire the event that we had created, that is property allotted, and it'll fire with the message that property has been successfully allotted. Next, we check for the function isOwner. So this is to check whether the owner has the said property or not. If yes, it returns the index of the owner. So basically we have set up a flag, and if that flag is anytime set to false because the property is not owned by him, we'll actually come to know. So first we go through the individual count of the property per owner and check the owner's address. And if the property owner says that it is sold, so we break out of the loop and we set the flag as true. Next, it's important to note here that if the property is owned, we are returning I, which is the index of the owner, and else we're returning a very large number, which is basically something that cannot be owned. So next, we also have a function called string equals, and this is to basically check if two strings that are being compared for the property name are equal or not. And this is a really neat way to do it, and we're using one of the inbuilt solidity functions called SHA-3, which basically runs a hash function on both the string indexes, and both the hashes will be the same if both the parameters are the same, even if one change in the message and the hash will completely differ. So basically we get a true or false depending on that. Next, we have the function to transfer our property, and this takes in the to address and the property name. So basically the address we're transferring it to and the property name that we want to transfer. And it also returns a boolean which will say if it was actually successful, and a uint saying which owner it has been gone to and the index of the owner. So first we put a check owner variable and we actually check if it is the owner or not. Next, as we had said, if it's not 999 basically and it's still not sold, we are going to transfer the property. So basically we just have two steps. We have to declare that it is now sold and we set the flag as true. Next, after the loop, the flag is checked, and if the flag is still false, we are firing the event that owner does not own the property. And if the ownership actually gets changed, we actually fire the event property transferred and the owner will be changed. So instead of explaining me all this, let's go and run this thing. So before we run this, we actually have to set up our test network. So open up command prompt and just type in Ganesh CLI, and that should just get us going. So we have our 10 accounts that we're going to fiddle with. So the first account out here at index 0 is going to be set as the DA. And we also have to set up Block Explorer. So just start Block Explorer 1 second. Next, we go to the Run tab and we change the provider to the Web3 provider. Click OK, and yes, indeed, our provider is running at 8545. So as you can see out here, the first address has been loaded up and we have 10 accounts to fiddle with. So we are going to deploy our contract out here now. So first we have to allot a property to an address. So let's take the first address and allot it some property. So we'll give our property the name property1 and click on allot property. Okay, so once we've set up our environment, it's time to deploy it. So click on deploy and we get all the functions that we created. So first we need to allot some property. So we're going to use the first address that we get with the Ganesh CLI thing. Copy the address for you, paste it, and give our property some name. So we're just going to call it property1. Okay, so once we've done setting up our network and our block explorer, we go into the environments and change it to the Web3 provider, and we'll see that all the accounts that are running on Ganache are available here for us to play around with. So now it's time we deploy our contract. So click on deploy, and we see that we get all the functions. So the two state changing functions are shown in red, that is allot property and transfer property. So first we have to allot the property to some address. So we take the first address, we copy it down here, and we get the property name, property1, and we commit the function. Now, as you can see here, that we have allotted the property, and you'll get the message property allotted successfully. We can even see the same in Block Explorer, and I'll show it to you in a short while. So now the main thing is we have to transfer the property. So we choose some other account, copy the address, come back to the same account for execution, and paste the address out here, and we're going to give it the same property that we just allotted it to the different address. So as you can see here, our transaction should be successful, and as you can see in our logs, we see that the owner has been changed for property 1. So now if this guy were trying to allot the same property again and again, that means there would be a double spending problem which is there in the central system. So on a decentralized network, this should be solved very easily. So let me just show you that double spending is indeed actually figured out. So if the guy tries to transfer the property again, so it should say that the property is not owned by him. So let's commit another transaction. And as you can see, we can't transfer the same property twice to say that the owner doesn't own the property. So let me just show you this on Block Explorer. So we visit localhost 8000. And as you can see, these are all the blocks that we've committed. So this must be the block. And as you can see, we can check all the gas that have been used, and we can see the transfer address to and the address from, and we can see everything, like it has 2 confirmation blocks above it. And also, yeah, this is a very neat part about blockchain. If you go to the 8th block, you'll see that it's an unconfirmed transaction. So that means it's still there to be mined. So if we go ahead and commit another transaction, suppose I want to do another double spending check and transfer this property again, you'll see out here that we've changed the state, and this thing will now get confirmed. As you can see, it has 1 confirmation above it, and that is this block, the 9th block that we've just created. So as you guys can see, if we use the property transfer use case on blockchain, we can actually solve the double spending problem in a very transparent and seamless manner. So this was just a very raw application with just a smart contract with no UI. If you guys want a UI, you can go to the Web3.js documentation and build a UI for yourself that can actually simulate this whole thing very intuitively.